Hello, welcome. We are covering the subject thermodynamics for civil service, main IFS and gate various gate exams. Now the next topic that we are discussing in this video for as an example of variable for programming charging and discharging of tank. And in the last video we derived that for filling up a bottle, this equation: change in energy of volume or control volume respect to time is equal to dq by d tau plus hp plus vp square by 2 dm by d tau. Okay. So now in case of charging there is no heat supplied, so dq is 0. Okay. In filling a bottle there may be heat supplied to the bottle, but in case of charging of tank there is no heat supplied, so this is 0. So and this change in energy of the control volume is only in the form of internal energy. So this can be written as mu, and this and we'll assume that the pipeline is having very low velocity as compared to, or very low kinetic energy as compared to its enthalpy. So we take this enthalpy term and we'll neglect this and we'll take this bigger. So this can be written as dnu is equal to hdn for a finite time. Okay. Or further solving it by product tool, it will be m du plus u dm, and this will be a h is your u plus pv, so it will be u dm plus pv dm. So u dm will cancel out. So dm by m is equal to du by pv. So this is equation number 2. So this is equation number 1 and this is equation number 2. So now if we take the volume of the tank, it is a constant quantity and it is equal to specific volume into mass. So that is a function of specific volume and mass. If mass is more, then specific volume is less. If specific volume is less, then mass is more. Okay. Or we can say, if we differentiate it, this quantity will be 0 and this will be a vdn plus md, or dm by m is equal to minus dv by d. Okay. More the mass in it, less will be the specific volume. If total volume will remain same as the mass will remain, so this quantity is constant, or dm by m is equal to minus dv by d. So this is equation number 3. Okay. So from 2 and 3, this is your 2 dm by m, and this is dm by m 3. So you can equate right hand side. So right hand sides are du by pv minus dv by d. So du is equal to p dv is equal to 0, or this is also the heat supply from the first graph from du plus p dv. Or again we have considered that in a charging of tank dq is 0, so it is again talking same thing. So now it means h dm, this is your h dm is equal to dm u. Or if you integrate it, it will be m2 u2 minus m1 u1, and this will be your hp m2 minus m, because mass is hp will remain same and mass is your mass, that is everything, that is m2 minus m1, m2 minus m1 is your m2. Okay. So now when the tank is initially empty, then u1 is 0, m1 is 0 and m2 is empty. It means hp is equal to u2 cp tp, because this is cp tp and this is cv t2. So it means cp by cv is your gamma, so t2 is your gamma tp. Similarly, when we consider discharging of tank, so this will get, because initially the there will be some internal energy and there will be some mass. There is m1 u1 and finally it will be replaced by m2 u2. If the tank is finally empty, then this m2 will be 0, m1 will be your mp, and again the same thing, but here u1 will be there, not u2, so h2 will be equal to u1 and gamma T2 will be equal to T1.